This is a project we started a few years ago and did some revisions somewhat recently based on some feedback we got after we had thought we had finished it. But we'll give a little kind of a very brief overview of kind of status and trends of water quality in kind of the lower sections of the Klamath River below Upper Klamath Lake. So this work, as to all of KBMP's work recently, has been funded by Caltrans. So thank you to Caltrans for that funding. We focused mainly on one big data set that was collected as part of the KHSA. That let us just all that data was going into CEDN, and so we were trying to get it in one place. The KHSA was a big collaborative effort related to dam removal with data collected by the Bureau of Reclamation, Pacific Corps, and the Karuk and Yurok tribes. All of it funded by Pacific Corps, so thanks to Pacific Corps for that big effort over the years. We had intended originally to include data for 3 additional years. But as we were doing the final steps to get that data into CEDN so we could get it analyzed, we identified some errors in comparing the data back to the original lab data. And so we're going back with that partner to try to look at their original database and how those errors occurred. And so that's still kind of something in process we're trying to work through. Time is always a challenge, unfortunately, with things like this, but it's a good reminder about data quality and having good quality assurance checks to make sure that what you're looking at is the correct values, so you can interpret it properly. So with that said, we're only looking at an 8-year data set. So when we think about trend analysis and trends over time, it's kind of challenging to really read a lot into it for that purpose. So in general, there were stations both in the main stem Klamath River, in the reservoir, and in tributaries where grab samples were collected. And then for a series of sondes that are out there in the main stem and reservoirs, as well as some sondes in the tributaries. So there is a whole lot of data that was collected as part of the KHSA, and we took a subset of that in order to analyze and address 3 specific management questions that relates to that status of water quality relative to existing regulatory thresholds from TMDLs, as well as species and life stage specific thresholds. And then we looked at trends in water quality conditions based on using these impairments and looking at them longitudinally, which is upstream to downstream, across years, and then across seasons or months. And then lastly, looked at the key relationships between different water quality parameters to see how that drives conditions in the basin. So things like dissolved to particulate, phosphorus, etc. So trying to understand how, as those change over time, what can we read into that. For the purposes of a short 15-minute presentation, we're going to focus on even a subset of these first 2 questions only. For looking at the Oregon TMDL, we looked at water temperature, pH, and dissolved oxygen, and we'll present that here in a bit. And then also total phosphorus for the California's TMDL. And then we looked at, for our status and trends assessment, we looked at a few parameters, chlorophyll, nitrogen, phosphate, and total phosphorus that we'll present here, but there were quite a few more that we included in the report. So you can, we'll share a link to that on the website, and you'll be able to kind of get deep into the weeds of box plots. So when we look at the Oregon's TMDL, there are criteria for temperature in the Keno Reach, where there are 5 sondes. Basically, 28 degrees C is the temperature that they don't want to exceed, and that was set up as a standard based on the presence of suckers. So we compared our data to that current TMDL criteria of 28C, but given that dams are coming down and salmon are about to be reintroduced into that reach, we also applied kind of the Oregon's criteria in other streams when there are cold water species present like salmon of 20 degrees C. So that's not the current TMDL criteria, but we wanted to look at it anyway just for the fact that they're about to be there. We also looked at, there was a couple different dissolved oxygen metrics. The one I'll present today is just for the absolute minimum of do not go below 4 milligrams per liter. And then there's also a pH range that's part of the TMDL, where you want it between 6.5 and 9. So what we wanted to use here to compare this information is looking at the percent days not meeting this criteria. And we were focused on the summer months of June through September for our years of 2009 to 2016. And so we have here, when we look at some of the data, we show that for that temperature, the current TMDL for temperature is 28, and 0 days throughout that whole time period exceeded 28 degrees. So that's good news for the suckers. But when we look at that, that actual value for 20 degrees C, that will be more relevant for salmonids, we see that, you know, around half or a little less than half of the days between June and September for these years exceeded that 20 Celsius water temperature criteria. So that's something, you know, that points to the challenges of trying to meet TMDLs, because, you know, this is water coming straight out of Upper Klamath Lake, which is a fairly shallow reservoir or shallow lake, and you know, does get fairly warm. So it's going to be challenging to try to meet that TMDL criteria moving forward. When we look at pH, again, pH less than 6.5 never happened. That's something that's just not, we don't really expect to occur just based on the, you know, the background water pH in the Klamath Basin, unless there was some sort of a, you know, industrial accident or something where there's some super acidic, you know, issue happen. But what we do see though is that pH exceeding 9 happens quite frequently. So at Link River Dam, which is, you know, the outlet to Upper Klamath Lake, 2/3 of the days the pH was exceeding 9, and you know, that's pretty extreme on its own, but quite often it was actually above 10. So that points to just the primary production that's going on in Upper Klamath Lake. It's pretty extreme, and something that really has downstream impacts as well. I'll point out in Kino Reservoir, there are two pairs of sondes that are deployed at Miller Island and a little bit downstream above Kino Reservoir or above Kino Dam. And because Kino stratifies in the summer, you'll have, you know, warmer water on top and then colder water below typically. So we see that somewhat in the temperature signal, but we also see it in pH. That water doesn't mix as well. So you get some very different water down in the bottom than you can in the top. And so we see that both in the pH, where the higher water column is not meeting the pH standard more frequently, is not meeting the standard more often than the lower water column. And then in dissolved oxygen, when we look at that absolute 4 milligram per liter standard at Link River Dam coming out of Upper Klamath Lake, it's very infrequent that it doesn't meet this criteria. That it's, you know, it's usually okay. But down in Kino Reservoir, where there's a lot of degradation of that organic material and algae that flows down from Upper Klamath Lake, we see these dissolved oxygen standards not being met, you know, roughly half the time. But beyond that, quite often it's actually quite a bit lower than that 4 milligram per liter standard. It's often even below 2 milligrams per liter. So it's a very challenging environment in the Kino Reach for salmonids. Moving downstream a little bit to Klamath River at State Line, we can look at the California TMDL for total phosphorus. And so different TMDLs are kind of have different metrics to measure by. And in California, they use a monthly average concentration as a numeric target. So these have been established. And it varies somewhat during the course of the year, but not a whole lot. But when we compare that against the actual values collected at Klamath River State Line, in general, they're quite a bit higher than what these numeric targets are. And you know, each of the months that we have here, they exceeded that numeric target concentration by at least 300%. So that's fairly significant, and that points to just the problems in the Klamath Basin with phosphorus and the challenges ahead for meeting that TMDL criteria and making progress towards compliance. So shifting gears away from those regulatory comparisons, we want to look at some of those trends. So talk about what are those trends longitudinally. And so want to make sure we can orient ourselves on this graph. So we're starting upriver at Link River, working our way down. Here's Klamath River, basically Shovel Creek is State Line, and then we get down below Iron Gate, and then all the way down to the estuary. So we can see declining concentrations of total nitrogen as we get downstream without a whole lot of to say here. And then if we look at phosphorus, we can see slightly lower values at Link relative to the Keno Reservoir downstream. And then again, declining, especially fairly rapidly once we get below the Scott River, which has a lot of additional contributions of water that's lower in phosphorus. On some of these graphs here, you'll see there are some outlier values. We'll just try to point those out, but that don't pay too much attention to them in the bigger picture here. So this is total phosphorus, and let's keep an eye on this Link River site here. Now, when we shift to total phosphate, we see the median values here at Link River is virtually non-detect, and yet when we go immediately downstream into the Keno Reach and below Keno Dam, we see those median values just jump way up, and then they remain pretty elevated through the reservoir reach, and then even a little bit below Iron Gate before they start declining again. So I think the difference here between total phosphorus and total phosphate has to do with what we're actually measuring and analyzing in the laboratory. It's basically this value here for total phosphate is not capturing that component of phosphorus that's bound up in the algae cells that are flowing out of the lake and some of that organic matter. So we just see a very different amount of phosphate in terms of what's available biologically. If we look at chlorophyll across these same stations, we had challenges with some of these graphs of how many outliers do we want, in terms of developing our axes to make this more easily viewed. But in general, we have pretty extreme primary production in Upper Klamath Lake that leads to very high values relative to everywhere else at the Link River station, and then declining a little bit at Keno, and then quite a bit more at the rest of the sites. Even just downstream of Iron Gate, we're seeing just significantly lower chlorophyll A levels than upstream. If we look at the values across years, and remember again, this is only an 8-year data set. So this is taking all these main stem river stations and combining them all, and then looking at that data again for each year. For total nitrogen, we don't see a whole lot of really great trends here. For phosphorus, again, this is the challenge of a small data set. We see maybe a slight decline, but it's hard to say it's a significant decline here. Total phosphate, again, a very similar, we have a decent range in the values, but nothing showing amazing progress. And then chlorophyll A, again, we have kind of just these conditions that are, I don't want to say it's definitely not constant, but we're not seeing any great trends here. And then briefly, if we look across the different seasons and by plotting everything with all years combined, all stations combined, looking at each month, no January here in these plots. For total nitrogen, we have kind of a lull in the May and June time period where we have kind of a slightly lower median and lower 75th percentile values, and generally higher concentrations in the fall and winter. So that's again related to biological processes that are taking that nitrogen up and putting it to use. In terms of total phosphorus, we see a somewhat similar trend, but a little bit more exaggerated total phosphorus concentrations in kind of the late summer time period. And then total phosphate, we see it's not too different than what we saw with total phosphorus. Again, just elevated concentrations in that late summer. And chlorophyll A, as we would probably expect, less activity in the winter months with kind of that summer and late summer higher concentrations. It was, there was a lot more data in the report, a lot more information to digest. I wanted to keep this fairly big picture and simple for the presentation today. But when we want to think about these things, We want to relate back to those TMDL criteria, tribal objectives, et cetera. When we look at most of the water quality parameters, they are frequently and often greatly exceeding the state or tribal criteria. So that points to just the challenges that we have ahead of us to try to restore water quality to the conditions that we would like to have. And a lot of this comes back to very high phosphorus loading into Upper Klamath Lake that drives some extreme cyanobacteria blooms in the lake itself, and then that drives some of these impairments that we see downstream, especially with dissolved oxygen and pH, things that we are kind of reflective of that primary productivity that's happening. And Keno Reservoir is probably the space where that is impacted the most, with basically anoxic conditions at time for good periods of the summer and early fall months. So it's a challenge. And Julie Alexander at yesterday's fish health meeting made kind of a comment about as we reestablish some of these new populations in the upper basin, we may expect to see some changes in the life history of how fish move in and out of the basin. Migrate upstream, out migrate. And so, that expansion beyond kind of what we typically see here with salmonids in the lower basin, we may be looking into some of those months where the conditions in Keno may not be ideal. And that's maybe being nice, may not be ideal for salmonids. So there's going to be some challenges there potentially at the edges of, the migration timing for salmonids. Until we can address the conditions in Keno Reservoir. When we looked at those status and trends longitudinally, we generally see that nutrient concentration decrease going downstream. And some of that's, dilution from tributaries that are typically of a lower concentration of whatever parameter we're talking about. And then we have primary production going on in the river itself, absorbing some nutrients and using them. And then sequestration through settling out of sediments and organic material in the reservoirs, which are now gone. And so now we have, quite a bit of that sediment has moved downstream and out to the ocean. Some has been retained up in the reservoir reaches and hopefully stabilized through, revegetation efforts, et cetera. But that piece of, the nutrient puzzle will not be factoring in as much moving forward. So be real curious to see how what's going to be happening. Maybe in the next few years we'll start to see some more stabilized trends. So kind of some bigger questions to think about as we talk about water quality in general and all the challenges we have to scale up, bringing these nutrient concentrations down if we're going to meet TMDL standards. And as many of you probably know, phosphorus is the one that we always point to. That is often the limiting factor in the algal bloom growth. And if we can address that phosphorus reduction through better land use practices, reducing erosion, I think we can start to really make a difference in that annual loading of phosphorus into Upper Klamath Lake, reduce that primary production and the cyanobacteria blooms, and hopefully try to get better water quality downstream. Kind of another question gets back to, how will dam removal change, the status and trends of water quality, both in the short term and long term. There's a lot of modeling that's been done before dam removal happened that, we can predict certain things. We've seen slightly warmer water temperatures this spring because those dams are not, holding all that cold water all winter and, getting that cold water inputs in the spring. So now we're kind of returning to a more natural water temperature regime so far. And then I think we would expect that water temperature in the fall for adult salmonids returning should be slightly cooler, again, given similar climate variables. So, there will be some changes there, but what else will change in terms of, nutrient concentrations and dissolved oxygen, pH, et cetera. So those are still some questions that, I think are ripe to ask moving forward through a follow-up report or whether it's using this same process or someone else doing a status and trends report later. And then the other question, because I use this hypothetical, water temperature criteria for water temperature in in the area where there currently were not salmonids, but there will be soon. I also did a similar one for pH because salmonid pH threshold is typically 8.5. I didn't show that here, and not 9. But will the salmon coming back into the Keech and Oregon itself, will that change the Oregon's TMDL criteria? I think is a question that we should be asking. So that is a very simple, quick update of what's happening with kind of that status and trends assessment. Happy to take questions and talk water quality.
Any questions for Randy?
I don't know about Oregon TMDLs, but it's clear that salmonids won't be there year round. That was, we've known that. But will they just apply TMDLs year round anyway, even though we wouldn't expect to find them year round? Like pH and temperatures.
I mean, it's maybe a question for ODEQ, but if we are starting to see salmonids moving through the Keno Reach at those times where there is high temperature or high dissolved oxygen or low dissolved oxygen, what do we do after that? So
I'm not advocating what we're
sure.
Wondering how to apply. Maybe you don't know, but maybe
Sure. Well,
I'll start thinking about it.
Yeah, I know with, there's a lot of groups that are out there doing a lot of pit tagging and other ways to track salmon migration for both juveniles and adults. And so I hope over the next few years, we'll start to see patterns emerge and we'll understand the timing more. And maybe it takes a few life cycles, I'm not sure, but I think it's something that, I don't think they'll jump at changing those to meet the salmonid standards for cold water fish right away, but we might have to have evidence that they are trying to use this Keno Reach during that time. But we'll see what happens.